Hello, welcome to all. Actually, we are going to discuss one important topic, that is power electronics. So, first of all, you should know what is meant by power electronics. So, you know already the electronics. So, what is meant by the electronics is to do it to deal with low power applications. Generally, we call as a electronics. So now if we control high power devices, if we control high power devices using electronic principles, so basically we are using principles of electronics. If we use principles of electronics in the high power, then we are calling as a power electronics. Now let us take a simple example, then we can tell why it is so called power electronics. Now say for example, you have a battery, okay, in this battery, and assume that there is a switch for this battery and there is a load here. So in this switch there is a load here, okay. So just try to draw, okay. Now what is actually happening? Now if I would like to see the voltage, so you always better to see the voltage, the voltage always, the DC voltage always represented in this direction. This is plus minus and this is the voltage, and this is the load, and the current that is passing through the load is I, and the voltage across this is V0, and this is the switch. So switch means either you can on and you can off. Now for instance, let us take an example. So this is V means voltage, this is I current, this is V0 the output voltage across this load, and S is the switch. Now let us see some important waveforms. In this waveform, I'll see, let me assume this V is 1000 volts or 100 volts. Okay, this 1000 volts. And so for this 1000 volts, I am drawing a, so this is the voltage and this is the 1000 volts. This is the voltage, this is the time with respect to the time in seconds. Now I want to know what is the output voltage here. So this is the input voltage, say we are calling as V in. So the output voltage we call as a output voltage V0. Okay, now when we call this as a output voltage, observe carefully. Now say for 1 second, you switch on the, you close the switch. Okay, for 1 second you close the switch. When you close the switch, the circuit will be closed. So the total voltage, since there is no assuming, the drop across this switch is assuming approximately equal to 0, and whatever the voltage is there, 1000 volts, the complete 1000 volts will appear across the output voltage. So the complete 1000 volts will appear across here, okay. Now after 1 second I instantaneously open the switch. So here what I did, I open the switch, I come instantaneously open the switch. Now when I open the switch, observe carefully, so suddenly the current is not flowing, so the voltage across this will become equal to 0. So for next 1 second, I have opened the switch such that the voltage here is 0. Now observe like this, and again for next 1 more second you have switched on and you have switched off. So basically if you observe this, since I told you for 1 second of time to switch on and for 1 second of time to switch off, you will easily tell me, yeah, so it is with the help of your hand, it is possible that to switch on for 1 second and to switch on for next second, and then to switch on for 1 second and to switch on for next second. Now I'll tell you, I'll tell you that, okay, switch on and off 10,000 times in 1 second. Can you do that? It is obviously difficult, but if it is low power, say for example, if your voltage is 1 volt or 10 volt or 5 volt, you may use some sort of small electronic devices like transistors. But though transistors are not for high switching purposes, so assuming it's having a reasonable switching, so we can use switch. But since it is a high power, but you should, I ask you to go for 10,000 times. So I ask you to go for 10,000 times, but it is high power. So that means I ask you to go for electronics principles in this. So this type of concepts like application of electronic principles, in power area, we are calling as a power electronics.